Hello everybody, welcome to Cumulative Review number 17, and let's start here with number 8. Write the quadratic function in vertex form, so we need to complete the square so that we can see the vertex. We want to find all x and y intercepts. So, now that we've done conics, this problem might be a little easier because we've done a lot more completing the square. But in order to complete the square, we cannot have a lead coefficient other than 1. It's not easy. So what we're going to do first is divide literally everything by 4. So we'd have f of x over 4 equals x squared minus 6x plus 17/4. But in order to complete the square, we just need the x's on the same side. So what we would do is we would subtract the 17/4 to the other side. We'd have x squared minus 6x plus blank. And on this side, we also need to do plus blank. And so our special number is always b over 2 quantity squared. So negative 6 divided by 2, negative 3 squared is 9. So I'd have to add the 9 over here as well. And so if I'm simplifying both sides, this factors to be x minus 3 quantity squared. And this side, if this is really 9 over 1, if we get a common denominator and multiply this by 4 over 4, this is really 36/4 plus f of x over 4 minus 17/4 equals x minus 3 squared. This side becomes f of x over 4 plus 36 minus 17 gives me 19/4 equals x minus 3 quantity squared. If I bring the work over here and try to continue to get f of x by itself, we would have f of x over 4 equals x minus 3 squared minus 19/4. And so now I need to multiply everything by 4 to get f of x alone. So times 4. This times 4 and this times 4. So these cross out and these cross out. So we're left with f of x equals 4 times x minus 3 quantity squared minus 19. So that would be my vertex form. Because now I can see in standard form what the vertex is. Specifically, now the vertex would be, remember the sign switches, 3, negative 19. If now I'd like to find my x-intercepts. X-intercepts, remember that is when y equals 0 because you're on the x-axis. We are going to set the equation that we just found equal to 0. So 0 equals 4 times x minus 3 quantity squared minus 19. And if my goal is to solve for x, I'm going to add the 19 first. And then I'm going to divide by 4. So I would have, if I switch the order, x minus 3 squared equals 19 over 4. And then, if I take the square root of both sides, this actually is not the worst, because I'd be left with x minus 3 equals plus or minus. The square root of 19 is just the square root of 19, can't reduce that, but the square root of 4 is 2, because this is really the square root of 19 over the square root of 4, which can be reduced nicely. The last thing I would do is add 3 to both sides, so we can leave our roots in exact form. We can leave them as 3 plus or minus the square root of 19 over 2, comma 0. The y-intercept is the best part of this entire problem because the y-intercept is when x equals 0. And so if we plug 0 into the original equation, if I plug in 0 here, that becomes 0. Plug 0 here, that becomes 0. So I'm just left with 17. So my y-intercept would be 0, 17. Next problem. Find the quadratic function in vertex form that has a vertex of -4, -5. So that's really h, k. And it passes through the point 3, 2, which is really x, y. We have a quadratic function, or a general form, which is f of x equals a times x minus h quantity squared plus k. And so what we're going to do is plug in everything we know and solve for a, and then plug what we need back in. What we need at the end is we need the a, we need the h, and we need the k. So here's what we have. F of x is really the same thing as y, and we know that y is 2. So we have 2 equals, don't know what a is yet. We know that x is 3 minus h is -4 squared plus -5. Please remember when you're doing this problem, don't forget the square. That's probably the most common mistake that I have seen. So we have 2 equals a times positive 7 to the second power minus 5, which is the same as plus a negative. If we continue to solve for a, and we add the 5 over here, we would get 7 equals a times 7 squared, which is 49. Divide both sides by 49. If reduced, 7/49 is the same as 1/7. So we now know that a is 1/7, so we can find the equation of our general form. 1/7 is a. The vertex is x minus h, which is x minus negative 4, which becomes x plus 4 squared. And then the k is minus 5. And so if I write this a little bit more neatly here, the vertex form of this parabola is this. So again, the goal is to know this green equation, find a, plug everything back in, and by everything, the most important items are the a and the vertex. Write as a complex number a plus bi. And so these are doing a bunch of different operations with complex or imaginary numbers. So part A, we want to simplify this as much as possible and get it in this format. So I to the 11th, what I'm going to do is split this into multiple i's and multiply them. My favorite I is I to the 4th, because I to the 4th is really 1. So I to the 11th is the same as I to the 4th times I to the 4th times I cubed, because together that is 11 of them. So that's how I'm going to start this piece. Minus 5 times the square root of negative 9 is really 3i plus 13. Please remember that I squared is negative 1, I cubed is negative I, and I to the 4th is 1. So I really have 3 times 1 times 1. I cubed is negative I. So this whole thing becomes negative 3i. This becomes negative 15i plus 13. Please make sure to follow the order of operations and multiply before you do any subtracting. So we did that. So my answer is negative 18i plus 13. But if we want it in a plus bi form, it would be the real part 13 minus 18i. Part B is asking you to multiply imaginary numbers, and so we are going to distribute. So the first thing I'm going to distribute is the 8. So I'd have 8 times 2, 16. 8 times negative 6i, negative 48i. Then I'm going to distribute the 4i. I would get positive 8i, and I get negative 24i squared. If simplified and combined like terms, we have 16. These are like terms, and that would be minus 40i minus 24 times I squared, which is really negative 1. This becomes 16 minus 40i plus 24, because of the double negative. So my final answer in a plus bi form, if I combine like terms, is going to be 40 minus 40i, because I combine these two together. Part C, it's extremely tempting to multiply these together first and make it a positive, but if you do that, you're going to be dropping some i's that we need. If you think about what this first piece really means, is 6 a perfect square? No. So this is really saying that we have I root 6, because if we take the I or the negative part out, it's imaginary root 6, and this would really be I root 20. Now root 20 can split. So we have I root 6 times I times the 20 is really root 4 and root 5. So this is really 2 root 5. So if we keep multiplying, I times I would get me I squared. Root 6 times 2 root 5 is really 2 root 30. Last but not least, I squared is really negative 1. So this is really negative 1 times 2 root 30, which is why the answer is negative 2 root 30. If you forgot to take the i's out at the beginning, your answer would have been positive, which would have been incorrect. Part D. This is a situation where we're going to need the conjugate, because we cannot have imaginary numbers in the denominator, much like we can't have radicals in the denominator. So we'd multiply top and bottom by 3 plus 4i. And if we do so, we would distribute the 7 on the top and get 21 plus 28i. In the denominator, if I'm multiplying conjugates, the middle terms always cross out. I'll show the work, but some of you may not need it. So if we distribute the 3 first, we have 9 plus 12i, and then we distribute the negative 4i, so we have negative 12i Then we have minus 16i squared. So the middle terms do cross out. I'm left with 21 plus 28i in the numerator. In the denominator, I'm left with 9 minus 16 times I squared is really negative 1. So I'm left with 21 plus 28i all over 9 plus 16, which is really 25. So if I keep extending the page here, we would get 21 plus 8i over 25, which, if written as a complex number, would be the real part, 21 25ths, plus the imaginary part, 8i over 25. Number 11, list the following about the given polynomial and then sketch. So before I start, I notice that my function is an odd degree or cubic, which means it looks like a snake. Because this is negative, that means that my snake is going to be falling from left to right, which will help with end behavior. The degree of my polynomial is 3. The leading coefficient is negative 1. Turns is always the degree minus 1, so it has 2 possible turns. The number of zeros is always the same as the degree, so there'd be 3 possible zeros. End behavior, if we look at our sketch, because we are falling from left to right, as x goes towards negative infinity this way, the function is increasing, so it's positive infinity here. As x goes towards positive infinity this way, the function is decreasing, so you're going towards negative infinity there. It's always very helpful to draw the picture. So now that I know what the graph should look like, I need to figure out what my x-intercepts are. And so to do that, we'd set our function equal to 0. And if I'm trying to factor this, let's see, we do have a greatest common factor. I'm going to take out a negative x to make my life easier. And I'd be left with x squared minus 8x plus 16. Just be careful about that sign there. If I continue to factor, this would be x minus 4 twice, which means that my zeros, if I set all of these equal to 0, would be x equals 0 is a possibility. This would be x equals 4, and this also would be x equals 4. So that means that the root of 0, 0 has a multiplicity of 1 because it occurs 1 time, but the root of 4, 0 occurs twice, so this has a multiplicity of 2. So what this means, if a root has a multiplicity that is odd, or a multiplicity of 1, this means it goes through the x-axis. However, if you have a multiplicity of 2, or an even multiplicity, that means it bounces off of the x-axis. So if I plot my points here, I would have 0, 0, and I would have 4, 0. I know that my function has to look like this, because I have a negative x cubed, so I'm falling. So I'm going to start somewhere up here. I'm going to go towards my 0, 0, and I'm going to go through that because it has a multiplicity of 1. And then I have to come back up towards my next root, but because 4 repeats twice, it's going to bounce here, and then my function is going to come back down. If this was a little bit neater at the beginning, I would say that it would be a little bit more straight up, but my graph would look something like this. Because it goes through 0, 0, bounces at 4, 0, and my end behavior is correct. So again, guys, instead of rushing to get number 12 completed, I'm going to do number 12 in the next video. Probably 12 and 13 will be completed in the next one. Thank you.